Hello guys, today we will be doing search a 2D matrix. So this problem boils down to binary search, but if you do not know matrix arithmetic, this problem is tricky. Um, so I'll do my best to explain it, but we basically have a matrix and a target. If the target is in the matrix, return true, otherwise return false. Okay, here we go. All right, so what we're going to do here is we're going to break our matrix into rows and columns, and we can do that using the dot length operation. So rows are going to be the first index of the array of arrays, and our columns are going to be the second indexes. So um, rows, there's one, two, three rows, and the matrix has four columns. One, two, three, four. Okay, each one of these inner arrays is the columns, and the outer ones containing the inner ones, those are our rows. So basically what we want to do is kind of in a way flatten this array of arrays, just turn it into one big array. And we're going to use the numbers that we can get um, from basically getting the size of it to calculate the middle. So we'll run our binary search from the very beginning. If you look at the matrix 0, 0 to the end 2, 3, and we have to find the middle point there. So if we do this, we can basically say there's three rows, there's four columns. So we multiply those together and then subtract one. That's going to give us the index of the end. And we can just use zero for the index of the beginning. And then we can divide that in half and we get this, 5, the index of our middle. Okay, and then next comes the tricky part. This is the matrix math. So we're going to use the middle index as a value in our equation so that we can generate the coordinates of the index of the actual value. So we're going to generate the coordinates in our matrix to get the value out of our middle. Our middle number and our left and our right and our rows and our columns, we're just using that. We're working up to this calculation because this is how we're actually going to get the middle value. All right, and the way this works is tricky. So the first calculation here, there's two arrays. The first one, we're going to round down math4 middle divided by columns. And essentially this works because each column has a length of 4 and our middle is 5, right? So if we divide middle by 4, it's going to tell us which one of these it's in. So, right, 1, 2, or 3. Since 5 is greater than 4, it's going to be in this first row, okay? And then for the second number, our column, this one is much trickier. You just have to remember that the relationship between an index, middle is an index, okay? It's the fifth index if this was a flat array. Just remember that it's an index, and the relationship between an index and its column is index modulo columns. And that will give us 1. So 1, 1 is our middle value. Before we step through it, I want to talk about the time complexity. So basically, the time complexity for this problem is the length of n times the length of m, and it's a log operation. So basically, log of n, it should simplify down to, because again, we're doing 3, 1, 2, 3 times 4, 1, 2, 3, 4, and then we're running binary search on that range, okay? So like this entire thing as if it were one array. And space complexity is constant. Okay, we have 6 variables and we're just storing a number in each one of those variables so we know the size of the space that we need. Okay, let's step through our problem. So for the first example, if we have this matrix and this target, let's go through the problem. So we have 3 rows and 4 columns, okay? 3 rows, 4 columns. Left is equal to 0 right here. Right is equal to 11, okay? That's our last index. 3 times 4 minus 1 will give us the index because of the 0 index offset. And so we start our while loop. While left is less than right, okay, we need to calculate our middle. Left plus right divided by 2, that will give us 5. We'll round down to get 5. All right, and then we just need the middle val, and that's where we use our tricky, our matrix arithmetic. So middle divided by columns, that's 5 divided by 4, and then middle modulo columns, 5 modulo 4, and that gives us 1, 1. These should be separate arrays, sorry about that, but yep, so we go into 1, 1, and our value is 11. Okay, so now we compare that middle val against our target. It is greater than our target, so we set right equal to middle minus 1. And let's see what that looks like. Bring number 2 up. All right, so this is where we go. Number 2, rows and columns are never going to change, so those stay the same. Left is still 0. We updated right from 11 to 4, so right is now here. And now we need to recalculate middle. Okay, so 0 left plus 4 divided by 2 gives us 2. All right, so again, this isn't actually our middle. We have to calculate it first to get the value, right? So 2 divided by 4. Okay, so middle divided by columns. That gives us 0. And we do 2 modulo columns, middle modulo columns. And when you do that, you just get 2. Okay, so now our middle is 5. Our middle val is 5. It's still greater than our target, so we set right equal to middle minus 1. And that should bring us here to number 3. All right, at number 3, rows and columns are still the same. Left is still 0. Right is now 1. Okay, so we calculate our new middle. 0 plus 1 divided by 2, that gives us 0. We set middle here, and we use that 0 number as our middle to calculate our middle val, all right? And that's going to come out to 0, 0. So our middle value is now 1. 1 is less than 3, so we have to move our left. Left gets set to middle plus 1, all right? And that brings us here to our last step. And left is 1, right is 1, and we're going to calculate our middle because we're still going through the loop. Left and right are equal. And that gives us 2 divided by 2 is equal to 1. So middle gets set here. We use that. 1 divided by 4 is 0. 1 modulo 4 is 1. So we have our middle number 3, and 3 is equal to 3. We finally hit this condition, and that's it. We just return true.